Hi everyone, we're going to start our 8-2 class notes. This is the second day and these are to be taken on April 2nd. So first the directions say to write each exponential. We see that they have exponents, so that's why they're called exponentials, as radicals. Assume that all variables represent positive real numbers, and they say that because under roots we know if it's an even degree we can't have negatives. All right, I'm going to go ahead and start my first example. Lots of examples today, so bear with me. Write this as a radical. Is the 5 being raised to the 3/5? No. 5 stays on the outside. Remember, the bottom number tells us the index. The numerator tells us the exponent. So this is the 5th root of x cubed. Okay, this is the base, that's the power. It is not in parentheses, so the 5 is on the outside, and this is where we can rewrite as a root. Fractional exponents mean root. Here I'm going to bring down my minus, and then I have the quantity being raised to the 3/5. So underneath my 5th root here, I have 2x, and the 2x is being cubed. If you wanted to cube the 2 and say 8x cubed, I would be fine with that. I believe the book leaves the answer just like this. So either way, some flexibility here. Okay, because of the addition sign, that makes this one strange. You can't take your exponent outside and multiply it with your exponents inside. That rule only applies if this is multiplication or if there was division going on. So I look at this exponent, see a fraction, and immediately know that it's a root. And I know that it's the cube root of this entire thing because it's in parentheses. Cube root of x squared plus y squared underneath that cube root. Done with the problem. Negative exponents always have to make positive first, make my fraction, and then I write it as a root. And here's the only case where we're okay with leaving a root in the bottom for now, because we're not gonna, the directions are just saying write as a radical and be done with the problem. So I can tell that this is the 7th root, and then I need to take the x to the 5th power. Okay, next slide of notes directions say write each radical as an exponential. Again, it's just saying to write it as the exponential and be done. So now I'm going the other way. I have a root. I need to write it as an exponential. What we have to remember here is the square root is the simplest form. So we have to know that the index here is a 2. You have to know that the index for a square root is 2, which means it's not just, a lot of students will write 37 to the first, but it's not. It's 37. A root represents a fractional exponent. We need a fraction, and we can't just write 1 over 1. It's going to be 1/2. Square roots, you don't see the index, but it should be known that the index is a 2. The index is a 2, therefore the fractional exponent would be 1/2. Final answer. And then again, this is my index, this is my denominator. This is my exponent, which is the numerator. So z being raised to the 8 over 8, understanding which one truly goes where because they're the same number, and that's not always going to be the case. 8 divided by 8 is 1, so we end up with z. Okay, let's move to the third page. I'm going to go to my computer so I can show you. Okay, these directions say to write with only positive exponents. So working with laws of exponents, adding exponents when you need to, subtracting them when you need to, and multiplying when you need to. And then again, it's always going to say, assume that the variables represent positive real numbers. We're going to work with these and keep them in exponential form. We are not going to write these as roots. So because I see parentheses, I'm going to take my negative 1/2. You can flip and make that a positive 1/2. I'm just going to work with them the way they are, multiply all of my exponents inside by the negative 1/2. I can do that because the only operation inside are multiplication and division. So I have x to the negative 3/2 and y to the positive 4/2, which some of you will just say is 2. And x to the 2/2, and some of you will just say is 1. Y to the negative 1/10. Okay, so now same base working top to bottom. I'm going to subtract my exponents. So I'm going to subtract these to get -3 minus 2. I'm going to work over to the side. -3 minus 2, right? Subtracting those is going to give me x to the -5/2. So I can't leave that. I need to have positive exponents. Here I need to get a common denominator of 10. So I'm going to multiply by 5 and by 5 and see that I have 20 over 10 minus 1 over 10. So I have minus a negative. So maybe I should write this out. 20 over 10 minus a -1/10. So that actually becomes a positive 1/10. And so I end up with x to the -5/2 times y to the 21st tenths. No reducing necessary there. Positive exponent here, we're good. We have to keep working because of the fact that I have a negative exponent. So I make my fraction, it's negative in the top. We make a move from the numerator to a denominator, it changes the sign of the exponent. Again, my positive exponent is going to stay in the top. Final answer. Again, write with positive exponents. Here I have an addition, no exponent outside. All this is saying, well, maybe you don't know, but think through what you're being asked to do here. And I hope you see that you're just being asked to multiply this with these, which means we're distributing. And so I'm going to write it out with those fractions. So I'm taking x to the 2/5 times x to the 3/5. Plus sign will come down. Then I take x to the 2/5 and I multiply it with x to the 8/5. And so now I see multiplication going on here, same base. I know that I can add these exponents. So I get x to the 5/5 plus x to the 10/5. And then I reduce. 5 over 5 is 1 and 10 over 5 is 2. These are not like terms. I could write this as x squared plus x. That would be standard form. So either way, but we can't do any additional work with that one because they are not like. All right, let's see what's next. 2 more to go. Write as exponentials. I'm going to go to my notes on the computer. Write all radicals, because these directions are longer. Write all radicals as exponentials. So we're going to write with exponents, not with the roots. Apply the rules for rational exponents. Leave answers in exponential form. And if we're in exponential form, we want all positive exponents in the end. So the reason we can't multiply these together is the rule would say that you have to have the same index to multiply these. Therefore, they're saying it's best to write it as an exponent first, or exponential first. So every root represents a fractional exponent. I hope that you know this is the numerator and the index is the denominator. So I'm saying x to the 3/4 times x to the, again, what would this fraction be? This would be 1/5. And so now when I write it this way, I can apply the rule that we just did in that last one. Same base multiplication going on, I can add the exponent. So I need to get a common denominator, which is going to be 20. So I have x to the 15/20 times x to the 4/20, and then I add the exponents, add the numerators, keep that common denominator, and I have x raised to the 19/20. Final answer because the exponent is positive. Last example for today, I have, this kind of looks like a math team problem to me in my opinion. So I have 2 roots and an x. I work innermost first. I'm going to keep that cube root and focus on writing this piece with my fractional exponent. So x to what power? Hopefully you're thinking 1/6. And now I need to take the x to the 1/6 and raise it to the, again, hopefully you're thinking this root would mean, the cube root as a fraction is 1/3. Now the rule says parentheses, take your exponent outside and multiply it with your exponents inside. We end up with x to the 1/18. X to the 1/18. All right, give homework a try and take a picture and submit. Try the best you can and let me know which ones you need to see worked through. Thanks everyone, have a great day.